Hello everyone. Today we are going to study an important topic from air navigation, which is Triangle of Velocities. Now before going to that topic, we need to study few of the basic definitions from that topic. So today we are going to first discuss the basic definitions and then move forward to the Triangle of Velocities. Now, starting with the first definition, which is heading. Heading is nothing but the direction in which the aircraft is pointing. Now, if I have to tell in the layman's language, then heading is the direction in which basically you want to go. If I say you have to go in the east direction, you will go this direction, right? Now, if I say you have to go in the north direction, you would go like this. Am I right? Similarly, if I talk about the aircraft, then the direction in which the aircraft is pointing or the direction in which the aircraft wants to go is its heading. The other definition for heading says the direction in which the fore and aft axis of the aircraft is pointing, that direction is known as its heading. Now, what is the fore and aft axis? As the name suggests, fore means the forward axis, the forward direction of the aircraft. Aft is nothing but the rear side or the back side or behind side. So this will be the aft axis. This is going to be a forward axis. So the direction in which the fore and aft axis of the aircraft is pointing, this direction will be the aircraft's heading. Now, if I ask you how to calculate heading, the simple answer is you have to calculate the heading from north, and that too in the clockwise sense. North can be either the true north, magnetic north, or the compass north, and you have to measure that heading in the clockwise direction. It has to be in the clockwise sense. What does that mean? In aviation, we use the sexagesimal system, in which we take a whole circle of 360 degrees, starting from the north, which is nothing but 000 degrees or 360 degrees. Then, if from this direction I go 90 degrees in the clockwise direction, I reach east direction, which is 090 degrees. Further, if I go 90 degrees, I will reach at the south pole or the south direction. So 90 plus 90 is 180 degree. If I go further 90 degrees, I will reach in the west direction, which will have the heading of 270 degree. Further 90 degrees and I will again reach the north direction. This is how we are going to calculate the heading. Now, if I say that my aircraft is going in this direction, what will be this aircraft's heading? As we have discussed, to calculate heading, first we have to get the north pole, then we will go from the north pole in the clockwise direction and till the direction where our aircraft is pointing, that will be the aircraft's heading, correct? So, let's begin our journey. This is the north direction. I have to go in the clockwise direction, which is this side, correct? Clockwise direction till the point where my aircraft is pointing. So, from the north direction, I am going till here. This is my aircraft. So the value of this heading is going to be between 180 degrees and 270 degrees, correct? So if the options are heading is 290, option B heading is 300, option C is 160, option D is 220 degrees. Out of these options, the only correct option is going to be the one which is between the 180 degrees and the 270 degrees. So in this case 290 will be cancelled out. Why? It is more than 270 degrees. 300 degrees, again we will eliminate this option because this is more than 270 degrees. 160, again wrong. Why? It is less than 180 degree. Our aircraft is here. So the nearest value for our aircraft's heading can be 220 degrees. I hope the concept of heading is now clear. If the heading concept is clear, you have to tell me heading for this aircraft, heading for this aircraft, heading for this aircraft. Assuming it is number 1, it is number 2 and this is number 3. Write down the answers in the comment below for number 1, number 2 and number 3. You can always tell me the nearest value, taking an approximate value for these examples. Take 5 seconds pause and tell me in the comments below. Now, number 1 will have heading between 90 degrees and 180 degrees. So you can take any value between 90 and 180. I'll assume the value to be 140 degrees. Number 2 is in the 4th quadrant and its value is going to be between 270 degrees, that is 270 degrees and 360 degrees. Let us take the approximate value of 290 degree. Number 3, this is between 000 degrees, that is the North Pole, and between 090 degrees, assuming the value to be between 0 and 90, which is 045 degrees. Now the next definition is track. The definition of the track is the direction in which the aircraft is going on the ground. The direction of aircraft's path over the ground. This is the aircraft. The aircraft is pointing in this direction. That means the aircraft is going in this direction. Let us assume it is going in the east direction. So it is going in 090 degree. Now the aircraft's path over the ground, assuming this is earth, the aircraft's path over the ground is this one, right? So even the aircraft's path over the ground is 090 degrees. What changes the aircraft's path on the ground, or what changes the trajectory of aircraft's path on the earth? The simple reason is wind. Because of the winds, the aircraft can be deviated from the path. Now, as we have seen that heading is always measured from the North Pole or the north direction, either it is true, whether it is magnetic or it is compass north. If we see track is also determined from the north direction and in the clockwise sense. Moving forward to the drift. Drift is nothing but the difference between heading and track. Now, before moving forward to the concept of drift, let us take a very basic example of a river. Let us assume that there are no currents in the river and the water is still. If the water is still, if I have to go from point A to the point B on the opposite end of river, what I have to do is simply take my boat and move straight. Now, if I assume that there are 5 knots of water currents which are coming from the left side of the boat, if I do not do anything, then my boat is going to be in the right direction as shown in the video. My concern is that I want to go in the direction exactly on the opposite point of where I started from. Where am I ending now? I am ending at a point which is not opposite of it. It is far away from that point, right? So where should I point my boat now. I should point my boat in the direction of the water currents. I should point in the direction where I face hurdles, but I will get to achieve my target, right? Now, instead of not doing anything, what we will do is we will point our boat into the winds or into the current or opposite of the flow, right? So now we will, since the water currents are from the left, and we will point the nose of our boat in the left, we can reach to the exactly same point as you can see in the video. So the change which has happened, the angle through which the boat changed its direction when it did not do anything, that is known as the drift. That means you just drifted from your path, right? So drift is nothing but the direction in which you were pointing and the direction in which you went. The difference between them is known as the drift. For example, if aircraft was heading 060 degrees and winds are from the left, where will you end up? You will end up somewhere here, right? Because someone is pushing you from the left. That means you are going towards the right. So, in this case, this is your drift. Say you reached a track of 065. Initial heading was 060, but because of winds, now you are maintaining a track of 065. You are not doing anything. You are simply getting drifted. You have not applied any opposite force. So this is your drift. The difference between heading and the track. Now, there is a terminology which is used in aviation, that is port and starboard. In aviation, if we have to mention the left side of aircraft, we call it as port side. If we have to tell the right side of aircraft, that is known as the starboard side. This is where the aircraft was heading. This is where the aircraft ended up. So did it end in the right side of its desired path or did it end on the left side of the desired path? Yes, it ended up on the right side of what we wanted. So the drift will be starboard drift. What will be the value of this drift? The difference between heading and track, which is 065 minus 060, that is 5 degrees in the starboard side. We denote drift like this, 5 degrees and S. Do we have any doubt here? Now, let's take one more example. You are heading in a direction of 300 degrees and you have winds from right. Because of these winds, you ended up somewhere here. Let us assume this is 290 degrees. You have to tell me what will be the value of drift. Here the heading is 300 degrees, winds were from the right, they were coming from the right, they pushed you and you went to the left of the track. So this is going to be your drift. This is where you were supposed to be, this is where you ended up because of the winds. So this is going to be your drift. To find the value of drift, you have to subtract heading and track, which is nothing but 10 degrees. And what will be the direction of this drift? Since we are ending up on the left side of the aircraft or the left side of our desired track, we will write P here because port means left side. We will use the terminology of port and starboard. Are we clear till here? If we are, let's move forward to the wind correction angle. So, as we have seen in that river example, if you want to go from point A to the opposite point B, or if you want to go to your destination and there are water currents, or in our case, if there are winds in between, what we have to do? We have to point ourselves into the winds and go like this in order to maintain a straight direction, right? Similarly, here, if we have to go in this direction, which is east direction, then we will have to crab into the winds. We call it crabbing, that you are going into the winds, right? Now wind correction angle is nothing but if there are winds and you want to correct or you want to compensate for the winds, then how much compensation will you give? You will give compensation equal to the value of drift. If you are drifting 5 degrees on the starboard side, you will go 5 degrees on the port side. That's why the value of the wind correction angle is same as that of drift. That is, if it is 5 degrees starboard drift, the wind correction angle is going to be 5 degrees. But it is in the opposite sense. That means, since the drift was 5 degrees in the starboard direction, the wind correction angle has to be 5 degrees but in the port direction. Now, this is a formula. Heading plus drift will give you track made good. If the drift is in the port side, we will use the value of drift as negative value. Now, if the drift is in the starboard direction, we will take the value of drift as positive. So, heading plus drift will give you the track made good, or basically the track which you are going to follow. In this formula, we are not compensating for the winds. We are just finding the value of our track, correct? We can apply this formula and solve the questions based on heading, track, drift, right? Now let's move forward to the triangle of velocities. The triangle of velocities will have three components. Number one will be the air component or the air vector. Number two is going to be the ground vector. Number three is going to be the wind vector. So we are going to discuss all of these three vectors in detail. Now, starting with the first vector, which is the air vector. The air vector consists of heading and TAS. What is TAS? TAS is nothing but the true airspeed, aircraft's speed with which it is moving, considered there are no winds. So air vector consists of heading and TAS, the true airspeed. The air vector is always represented by a single arrow. Now, let us look at the second vector in triangle of velocities, which is nothing but the wind vector. Number two is wind vector. This vector consists of the wind speed and the wind direction. The wind speed and direction. In meteorology, we must have seen how do we denote the wind speed and direction. Wind speed can be represented like this, 270/15. Here 270 is the wind direction and 15 is the wind speed given in knots. This is how we represent the wind speed and wind direction. Also, 270 degrees 15 knots means that the winds are coming from the direction 270 at 15 knots of speed. So how would it actually look like? This is how 270 degrees is going to look like. The winds are coming from 270 direction. Basically, the winds are starting from 270 and from 270 they are going towards 090. So this is how we are going to represent the winds. So this is how we represent the wind vector and we write the wind speed and wind direction in this way. Now we will move forward to the third vector. The third vector is nothing but the ground vector. This ground vector consists of adding up the first two vectors, which are the air vector, and we add the wind vector. And what do we get? We get the ground vector. This ground vector consists of track and ground speed. This is represented by a double arrow. So remember, the air vector is represented by single arrow, the ground vector is represented by two arrows, and the wind vector is represented by three arrows. Now, let us look at how the triangle is going to form. Since we know that ground vector is formed when air vector and wind vectors are added up. Now let us look at the triangle of velocities and how are they formed. So the first vector is the air vector. Here comes our air vector, represented by a single arrow, and it consists of heading and true airspeed. In this vector, if I add the wind vector, which is represented by three arrows, this is wind vector, which consists of wind direction and wind speed. Then we get the resultant of these two as the ground vector, represented by two arrows, and ground vector consists of track and ground speed. The angle between this heading and the track, since we know this is nothing but the drift, this is the drift angle between both of them. So this is how a triangle of velocities is formed. What the triangle of velocities is trying to tell you basically is that the difference between heading and track is drift. So we are representing the drift here, and the TAS is nothing but the true airspeed of aircraft when the winds are still, or you can say there are calm winds, there are nil winds. So TAS is considered to be calculated in nil winds. But in actual life, is that so? No. We do have winds on certain days, just like the monsoon is going on right now, so we will have a lot of wind. So if I include the wind factor, then the change in TAS which has happened because of winds is known as the ground speed. Now, how are the questions actually asked in the paper? In DGCA, you might get at least 2 to 3 questions just simply based on the basic formulas or the basic formulas of triangle of velocity. What is the first formula? First formula is heading plus drift gives you track made good, right? And here we are taking the drift as positive when the drift is starboard, and in that formula you are taking the drift as negative if the drift is on the port side or on the left side. Now, the DGCA questions can be asked in this way. Heading is given, wind speed and wind direction is given. They are asking you track made good. TAS is given, then they'll ask you the ground speed. Now, to move with these questions, you can use CX3. CX3 will directly put the values and we will get the answer. So, going to the CX3, just to practice it here online, we have one website. Just type the CX3 in the Google and you will get the first website there. In that website, we will go down to the wind correction. Very good. Now, in that wind correction section, we are going to put the value of true heading. In this case, our true heading is 273 degrees. So, we will put 273 degrees in this section. Now, moving forward to the track, the true course which we are supposed to find, which is nothing but the track made good. We are supposed to find this value, correct? Next, going down, we will get the option for wind speed and wind direction. From here we know that the wind speed is 40 knots and the wind direction is 230 knots, right? In that section we will mention the values of each of them, 230 degrees and 40 knots. Next, on the top of it we are given the option for TAS. We will put the value of TAS as 150 degrees. Now by using CX3, these types of question became a piece of cake, right? So what values did we get? We got track made good, or you can say the true course 286 degrees nearly, and the ground speed to be 124 knots. So this is how the questions will be asked, right? If you like this video, do let me know, and what next topic do you want to understand for the air navigation, just let me know. Thank you.